Okay guys, so now we are going to discuss the next part of module 4, which is about keyboard or monitor. So first we will start with keyboard or monitor. These keyboard and monitor and all is a character based communication devices. That means here the basic unit of exchanging, that is here the data is basically basic unit of exchanging that is happening here is mainly in the basis of if you see, it is basically the basic unit here is character. Okay, this character can, how many bits this would be this character, that is it can be like, if you see, 7 or 8 bits would be the length of each of this character. So unlike processor that works with raw binary numbers, keyboard and monitor is dealing with characters. So processor, we know it works with binary numbers. Keyboard and monitors are dealing with these characters. The characters can be letter, digit, symbols. Now each of this have a 7 or 8 bit length. Okay. Now every character is represented as a unique binary code, so the computer can process and store it digitally. So you have to understand every character, whether it be a letter, whether it be a digit, whether it be a symbol, they are basically converted into the binary code so that it can be understood by the processor. So here the basic unit of exchange is character. Okay, the characters means what? Letter, digit, symbols and all. Now IRA is the standard character code. That means the most commonly used test code is the International Reference Alphabet, IRA. Okay, International Reference Alphabet. Each character in this code is represented by a unique 7-bit binary code. Thus 128 different characters can be present because we know 7 bits are there. So 7 bits means 2 raised to 7, we know 7 bit is a unique 7-bit binary code we can represent each character. So that means we can have 128 different unique codes. Okay. So this is essentially what most people know as ASCII code. This is what ASCII code is actually, that is the International Reference Alphabet. The most commonly used test code is this International Reference Alphabet, and here in each character would be represented as a unique 7-bit binary code. So therefore 120 different characters are basically there. So if you see, there are two types of characters: printable characters and control characters. Printable characters, the characters that appear visually on the screen are printable. But that which is actually controlling, like new line, tab and all, which create backspace and all, these are control characters. Some of the control characters have to do with controlling the printing or displaying of characters. So that is, control characters is how we display and printing and all that things controlling characters basically do, controls. The control characters are invisible. We cannot see this, like these space we can see, but we cannot have a character for that space, right? So they don't produce a symbol, but instead instruct the device how they have to behave at that particular time, like moving to a new line or clearing the screen. That is what these control characters do. Printable characters are those characters that you can see, visually see it in the screen, but control is the actually controlling the display part. They control the display or print behavior. These are the new line, tab, return, backspace. These are the characters which is actually controlling the display or print behavior is done by this control. Now printable is those which is appearing visually on the screen or paper. Such characters are the printable characters. Okay, so ASCII code, we have to understand that the text code which is commonly used text code is International Reference Code, which actually contains, so here in each of this character in this code is basically you can represent it as a unique 7-bit binary code. So therefore total you can have 128 different characters you can represent. This we have to understand. This is a standard character code, the standard character text code. Okay, so now we can understand the next thing, that is then we talk about that there are different two types of characters, that is we have the printable characters and we have the control characters. Printable characters are those characters which you can see visually on the screen, but control characters are those characters which is actually controlling the behavior of the displaying, and the printing behavior is controlled by this control characters. So this is about keyboard or monitor. So in keyboard or monitor, the basic unit of exchanging is basically character. There will be a 7 to 8 bit would be its length. So for the computer to understand, you have to convert into a unique binary code, which is through this IRA. Okay, this is what we mostly known as our ASCII code. understood, and we told that there are basically two types. Characters can be of two types. We can have printable characters and which we can have control characters. Fine. Next we are going to talk about, like how we discussed our keyboard or monitor, we are going to talk about disk drive. Electronics and mechanism. A disk drive contains electronics for exchanging data, control and status signals with an I/O module, plus electronics for controlling the disk read or write mechanism. A disk drive have two set of electronics working together. One handles the communication with I/O module and the other controls the physical read or write hardware. So you have to understand here, the disk drive contains what? The disk drive contains electronics. This electronics help for exchanging. There are two types of electronics. One is handling the communication with I/O module. So with the I/O module, we are basically sending data, controlling status signal, right? So to control this, there is one electronic which is present in our disk drive, and the other electronic is used to control the read or write mechanism, read or write hardware mechanism. To control that, that is the arm, the head and the motor. To control that in the disk drive, then there is another electronics. Okay, so you have to understand the disk drive contains two set of electronics. The one electronic is used to handle the communication with the I/O module, that is the data, control signals, such things. Okay, and the other is controlling physically the read or write hardware, that is the arm, head and the motor. Now there is a fixed head disk. In a fixed head disk, the transducer is capable of converting between the magnetic patterns on the moving disk surface and bits in the device's buffer. In a fixed head disk, the read or write head stays stationary. It doesn't move. The disk surface spins beneath it. The transducer, the reading detects the magnetic patterns on the spinning disk, convert to bits in buffer. Writing take bits from the buffer and convert to magnetic patterns on the disk. So you have to understand that basically two kinds of, that is fixed head disk is also there, moving head disk is also there. Fixed head disk means that the head or the, what we are talking about here is that in the fixed head disk, what happened is that the read write head would be there, that would stay stationary, it doesn't move, and the disk surface, that would spin. So what does the transducer do? The transducer, while it is reading, means the transducer would detect this magnetic patterns in that spinning surface of the disk, and it will convert it to bits in the buffer. Now what is writing happens? In writing, the bits which is present in the buffer, you can take it and you can convert into the magnetic patterns into the disk. That is how writing happens. So you have to understand, first of all, in disk drive, the first thing that you have to understand, there are two set of electronics which is working together in the disk drive. The first electronics is handling the communication with the I/O module, that is the data, control and state signals, and the other is basically used for the, and the other electronic is basically handling what? The controlling the read or write things which is there, physically controlling the physical read or write hardware, that is controlling the arm, head and the motor. So you have to understand, in the disk drive there are basically two types. The fixed head disk is also there, moving head disk is also there. Fixed head disk means what? Here what happens is that the head part, that is the read or write head part, doesn't move. Only the thing which moves is my this magnetic spin disk which is beneath this head, that would move. So the transducer, while it is reading, it will take what? This magnetic spin is moving, so that magnetic patterns it will detect and it will convert into bits and store it in the buffer. Now writing means what? Writing means the bits which is there in the buffer, it will take that and will convert into the magnetic patterns which is present on the disk. Now in a moving head disk, what happened is that a moving head disk must also be able to cause the disk arm to move radially. That means in a moving head disk, that is a standard hard disk drive, that is HDD, the arm physically is sweeping across this disk surface to reach a particular different task. So this adds a mechanical complexity. So the drive must precisely control this arm position in addition to reading or writing. So what happened here is that the drive must precisely control arm position. Here what happened is that arm is moving rapidly here and there is a spinning disk plater over, so both of them are there. So there is a mechanical complexity also. So what happened is that the drive must also control this arm position in addition to reading or writing. Spinning disk plater would do reading and writing, but to reach a particular track we have to control this arm. So here the arm physically is sweeping across this disk surface to reach the different track. So this would happen is that there is a mechanical complexity. Why we are saying that there is a mechanical complexity is because the drive has to now control the arm position in addition to reading or writing, right? So a moving head disk must also be able to cause the disk arm to move radially in and out across this disk surface. So there is a mechanical complexity which is there along with the other thing. But in the other case, that is in the fixed head disk, there was no mechanical complexity there, but here you can see that there is a mechanical complexity also which is there in here. Okay, so while we are learning the disk, the things that you have to understand that the disk has two electronics, one which handles the communication with the IO module and the other is for the hardware, physical read or write hardware. Fine. Now there is a two types of disk drive. One is the one is basically the fixed head disk and the other is basically what, the moving head disk. Now fixed head disk means what? Fixed head disk means here the head is fixed and the spinning magnetic disk is moving. So the transducer reading is that detecting the magnetic patterns in the spinning disk and it will convert it into bits in the buffer. Writing means taking the bits from the buffer and converting into magnetic patterns on the disk. A moving head disk means there is additional mechanical complexity because we have to make sure that arm is basically there in the right position. So the drive must precisely control the arm position in addition to this reading or writing. Now we are going to talk about IO modules. So IO modules has 5 major functions. We know what is IO modules. It is an interface between our external devices and our computer system. So IO modules, you have to understand there are main functions which is done by this IO module. The first is control and timing, processor communication, device communication, data buffering, error detection. Okay, so these are the main 5 functions which is basically done by this IO module. Okay, so let's understand the first function, that is control and timing. Okay, I'll zoom it for you if you want. Now control and timing, during any period of time the processor may communicate with one or more external devices in unpredictable pattern depending on the program's need for IO. Okay, you may not have understood anything, but let's understand this very clearly. Here you have to understand that the CPU doesn't access device on a fixed schedule. There is no fixed scheduling and all to access the device. The IO request happen whenever the program needs them. Whenever the program needs any IO things, what happened is that there is no particular schedule and all, only at that particular time only I can access the device. No such thing is there here. Okay, so here what happens is that basically you have to understand that the IO request is happening whenever the program needs them. It is unpredictable. There is no particular schedule or pattern in accessing the device. So the IO request happens whenever there is an IO request. IO request would happen whenever the program needs something from our external device. At that time the IO request would happen. So it's happening in an unpredictable manner. So you have to understand that. Meanwhile, the system bus and the main memory are shared, the resources being used by multiple activities simultaneously. Now we have told that there is system bus. System bus is actually transferring all of these CPUs, all of the things that it requires, and from the external device whatever data and all, through the system bus this transferring is happening from the IO module to these CPU. So and main memory are shared resources being used by multiple activities simultaneously. So there are a lot of things, a lot of resources already there because there are a lot of activities which is happening, multiple activities are happening simultaneously. So what happened, lot of resources are shared which is present in the system bus and main memory. So the IO function includes a control and timing requirement. A control timing requirement is needed For what? To coordinate this traffic between the internal resources and the external devices, right? So there is a traffic, so a traffic controller is needed. So IO module can act as a traffic control, because we are talking about the function of IO module. So IO module act as a traffic control by including a control and timing signals, control and timing requirements. So this IO module would manage when each device gets access to the shared resources, preventing conflicts and ensuring an orderly data flow. So what is happening here is that we have understood there are some shared resources which can be accessed by our devices also, and also by it is already multiple activities is happening simultaneously. So these shared resources are also being used, that is the system bus and the main memory. The system bus and the main memory are shared resources here, so that can be used by multiple activities which is happening in our device. So this shared resources like the system bus and main memory, because we know here in this diagram when we check, we understood that the system bus, through the system bus only the whatever the devices needs can be getting from the system bus, right? So the system bus and the main memory can be used for accessing a lot of data, and all they will be always busy. These are the shared resources, they may be busy in other activities also. So whenever IO request happen, it is happening very unpredictably. So what happen is that these shared resources access should be controlled, that is managed. We should manage when each of these devices is getting access to this shared resources like the system bus and the main memory. Then only we can prevent conflict, and also ensures that the data flow is happening orderly. So our IO module would act as a traffic controller by creating control and timing requirements. So if you see here, this is the data transfer sequence which would happen. The CPU, when its CPU needs is doing some program, is executing one program, and at that time the program needs IO module. So what do is that CPU asks the IO module what is the device status. So IO module would reply the device status whether it is ready or busy. If it is ready, the CPU send command to transfer the data. So IO module fetches a unit of data from the device, and the data is transferred from the IO module to the CPU. This is the control of the transfer of data from the external device to the processor might involve this sequence. This is how the data sequence is basically happening here. So this would ensure that the data is only requested. Data is only requested when the device is actually ready. First we have to check the device is ready or not. When the device is ready, then only the data is requested. So this would prevent errors and lost data to happen. So there is a control and timing means, first we with the CPU would ask the IO module whether the device is ready or not. Whenever the device is ready, then only the CPU would request for data. Then only the data is transferred from this device to the CPU. Okay, then only this would happen. So this timing and control and timing means that there is a status, device status, first the CPU has to check. So through the IO module would not IO module, what it will do, it will directly ask this device its status, and we get the status, and that is given to the CPU. So this happens only with the help of IO module. So to access the shared resources, when this devices can access the shared resources is basically managed by whom? It is managed by the IO module to prevent traffic, to control the traffic. If it doesn't do such data transfer sequence, what happen is that there can be lot of errors and lot of data can be lost. Okay, so in this control and timing, the things that we have to remember is that while the CPU is doing some executing some program, it will the program may require IO modules data and all. So that is unpredictable when it requires this data. But sometimes the CPU, the device may not be ready to give the data. It may be busy accessing some other shared resources and all. So this IO module would act as a traffic control by giving this control and timing requirement. How? It will manage how when our devices can access the shared resources. So this can prevent conflict and make this data flow orderly. So the correct sequence is that first the CPU would ask the IO module what is the status of the device. Then IO module would reply. If it is ready, it will say ready. If it is busy, it will say busy. Then if it is ready, then only the CPU would send command that it needs some data to transfer. Okay. So IO module, what it will do, it will take some unit of data from the device, and from the IO module that data has been transferred to the CPU. So there are 5 steps. So this is how it is happen. If there is no this checking, that is this handshaking ensures data is only requested when the device is ready. This can prevent error and lost data. So this is the first important function, that is control and timing. Now the second function of IO module is processor communication. The IO module must communicate with the processor. We know command decoding, data exchange, okay, and status reporting, address recognition are the things these things is happening between the IO module and the processor. So there is a processor communication can only happen through what? It can only happen through this IO module. So if you see here, command decoding means the IO module would accept command from the processor and typically send signals on the control bus, right? So that means the IO module would receive some commands, that is from the CPU. It will interpret this command. Okay, if a disk drives, IO module understands commands like read sector, write sector, seek track number, scan record ID. There are different commands. So read sector, if it's disk, then read sector, write data to a specific sector, seek the time, move the direct arm to a specific track, scan record ID, search for a specific record. These commands can be understood. So there are some commands which the CPU is giving. So the IO module, what it has to do, it has to accept that command from the processor. It has to interpret, it has to decode that command. Okay, it has to interpret this command code, and it has to typically send a signal, that means a command from the processor. How this command is coming to the IO module from the processor? Through this control lines. Through this control lines, the command would be given to the IO module, what it has to do, and that command would be interpreted here by the IO module. So IO module would accept this command which is coming through the control lines. Through the control lines, these commands can come from the processor, right? And the IO module would accept this command, interpret this command, and do accordingly, right? So that is one example. Command decoding is the first thing that is there in processor communication. So here what happened is that a disk, so here if you see disk example, the commands that the IO module would understand is the read sector, write sector, seek track number, right, seek track number, scan record ID are the different commands it would basically understand. Okay, scan record ID, fine. The next thing is data exchange. Data is exchanged between the processor and the IO module over this data bus. Now you can see between this IO module and the processor there is this data lines. Through this data lines, that is through this data bus, the data can be exchanged between the IO module and the processor. Fine, that is why we have data exchange. Actual data is traveling through this data bus, the shared highway between the CPU memory and the IO module. That is data exchange. Now status reporting. Now we have discussed before also, status reporting. IO module would give the status to the processor. Since devices are far slower than the CPU, what happens is that the CPU always has to check before sending the data, or whether if it needs anything, the CPU is always faster, device is slower, so it always has to check the data. So it always has to see whether the device is ready or busy. So that status is given by the IO module to the processor. Now next is address recognition. An IO module must recognize one unique address for each peripheral it controls. That means Just like memory locations have address, each of these peripheral devices also should has a unique address. So the IO module monitors this address bus and only respond when it sees its own address. Similar to, so that means IO module must recognize one unique address for each peripheral it controls. That means in the address line, the address of the, like, each peripheral has unique address. So the IO module would only it will always monitors this address bus and it only respond when it sees its own address. That is, it's like when you see your own name only we will respond. In the similar way, the IO module would only in the address bus, if it see its address only it will respond. So each of these peripheral devices has its own address, unique address. So IO module, we know it has been connected to different peripheral devices. Each must be recognized one unique address for each of these peripheral devices in which it is connected. So if we consider our processor communication, what are the things which is happening is, first thing is command decoding. So first, command decoding means what? In the command decoding, the processor would send some commands into which bus? To the control bus. As we have seen in this image, we can see that through the processor would send some commands to this IO module through this control line buses, and then the IO module has to understand, accept this command and should interpret this command. Okay, the next thing it is doing, it is what is the function that the IO module does is what? Command decode. After command decoding, the next function that the IO module do is this: data exchange. Data exchange means, that is processor communication itself. Data exchange means that through the data bus, the exchange of data would happen between the processor and the IO module. Okay, then we have the status reporting. Then we have address recognition. That is the IO module would always check this address bus. When it sees its own address only, it will respond. That is address recognition. Each of this peripheral device has its own unique address. So in the second function of the IO module, we have processor communication, which includes command decoding, data transfer, data exchange, I would say. Then we have status reporting, then address recognition. Other four things which is included in the processor communication. Now the third function that the IO module do is device communication. The IO module must be able to perform, like it communicate with processor, the IO module communicate with whom? The devices. That is, how this communication is involved. This communication involves command, status information and data. Okay, the IO module must speak two languages simultaneously: the high speed language of the CPU or the buses, and the device specific language of each peripheral device. It acts as a translator between these two worlds, that is the high speed CPU, high speed language of CPU, and the device specific language of peripheral. Each of these devices has its device specific language. So this would act as a translator between this. So device communication can happen, that what are the communication includes what? Command, status and data. Like how it communicates with the processor, the IO module must also has to communicate with the device. Okay, so this, in short, we can say that this IO module has to speak two languages simultaneously. First is the high speed language of the CPU, and next is the device specific language of the peripheral device. So we can say it acts as a translator between these two, whom? With the CPU and with the peripheral device. The fourth function it does is data buffering. Now what do we mean by data buffering? So an essential task of IO module is this data buffering. Data coming from the main memory are sent to IO module in a rapid burst. The data are buffered in the IO module and then sent to the peripheral device at its data rate. That means main memory speed is nanosecond, peripheral device speed is millisecond. So there is a speed mismatch between the CPU or memory and peripheral devices. This is enormous. Rapidly the data coming from the main memory are sent to the IO module very rapidly at a burst time. Rapid burstly you are getting that within nanosecond. But peripheral devices speed is millisecond. There is a lot of time difference between them. So if there is no buffering, one of the two bad things can happen. What? The CPU waits ideally while the slow device is processing this data and giving the information to the CPU, or the CPU would become idle. Sometimes the data is lost between the devices because the device can't keep up with this. That is known as the catastrophic problem. So here, if there is no data buffering, the CPU must wait for the waits ideally, and it will, because our devices is very slow in processing our data. And the second thing is that the device is not able to catch up with the speed of the processor. So what happened is that our data may get lost. That is problem known as catastrophic. So the buffering solves this problem. What happened is that the memory fastly would give some data to the IO buffer. In the IO module there is IO buffer. So after that, only slowly the data are buffered in the IO module, and then it is sent to the peripheral devices at its data rate. That is, IO buffer would send this data to the devices slowly. Now sometimes device is sending slowly the data to the IO buffer. So IO buffer, what it do is that it will able to send it fastly to the memory, rapid burst. So it actually adjusts this mismatch between the CPU, memory and the peripheral devices speed gap. Okay, so buffer absorbs the speed difference, filling quickly from memory and draining slowly to the device. Like it is filling this, absorbing this speed difference. That is what it do. So thus the IO module must be able to operate at both device and memory speed. So IO module has to be able to operate at both of this devices speed also, memory speed also. Understood? So that is what it do. Data buffering means main memory and peripheral devices a huge difference in the speed. The data can be sent from the main memory to the IO module at rapid, but the data, so what happened, the data would get buffered, then it will be sending to the IO module slowly at its rate. At its rate it can send, right? So if there is no buffering, what happen is that the CPU may go idle for a lot of time and the data may also get lost. That is catastrophic problem. That is waiting and catastrophic problem are the two problems which is basically happening here. So you have to understand the two problem which is happening here. The first is a wasting problem and the second is the catastrophic problem. Because of this problem, the CPU, because of these problems, there is this IO buffer which helps to absorb this speed difference between these devices. Understood? This would have, that means this IO module can operate in both of this device and the memory speed. It can operate at both of this device and memory speed. So that is the another function that the IO module do. Now next is error detection. Now the IO module is also responsible. I know it's kind of lengthy. Fine. IO, this is like only 2 more slides. So IO module is also responsible for error detection. That is, for subsequently reporting error to the processor. That is, there is mechanical or electrical device errors can happen and transmission errors can also happen. One class of error is including this mechanical and electrical device malfunctioning error, okay, which is reported by the device itself. Like in the printer, the paper got jammed, the bad disk track, like that. So physical problems with the device itself, hardware failures that the device detects and report to the IO module, which then reports to the CPU. So there are hardware failures that can happen in the device, electronic and mechanical malfunctions which can be reported by the device. So the device can have some errors, like some electrical, mechanical errors the device can have. So those errors are reported to whom? These errors are reported to the CPU. By whom? These errors are reported to the CPU by our IO module. So this is the first function. So the mechanical error means paper jam is a mechanical error. Electrical magnetic error is like bad sector on the disk, electrical device overheating. So these are the different errors that can occur. So this errors, that is this hardware failures that is happening in the device detects this and report that to the IO module, which then report it to the CPU. This is the first error. Next error is this transmission error. Electrical noise or interface can flip bits during transmission. A 0 can become 1 or vice versa. So error detecting code like parity bit or cyclic redundancy check are added to the data so the receiver can detect if any bits were corrupted in the transition. So there can some electrical noise or interference can come, so that while your transmission means while you are transmitting time, the data transmitting time, the bit can get flagged, 0 can become 1 or 1 can become 0, like that. So error detecting codes will be there, that is parity or cyclic redundancy check will be there. Okay, these error detecting codes are added to the data so the receiver can detect if any bits get corrupted. So during the transcription, noise flips a bit, that means if you see this 1 becomes 0. So parity, using the parity or the cyclic redundancy check that is present, that is added to the data so the receiver can detect if anything is there. So error check fails, so report error to the CPU using this parity or cyclic redundancy check which is there to the data. These error detecting codes are added to the data itself, so this helps the receiver to check if there is any problem in the data that we have transmitted. So this error, it will check this error detecting code, using this error would check and it fails. If it fails means report this error to the CPU, then it will report this error to the CPU. So this is done by whom? The IO module. So this is the second class, that is the transmission error. So this is a whole summary: control timing, processor communication, device communication, data buffer, and error detection reporting are the different functions which is done by our IO module. Thank you.